Okay, so let's review the sum and difference formulas for sine, cosine, and tangent. So I've got the cosine of two angles that are being added inside. Unfortunately, I cannot just distribute this cosine to each angle. Okay? The cosine is not a linear operator. I cannot just pull it through the plus sign. Okay? So the formulas come out to be more complicated. So let me write them out for you. Okay. So I've got the sum and difference formulas for cosine, the sum and difference formulas for sine. Okay. Now, to write these identities, I'm going to just take the angles in the order in which I see them. Okay, so I've got AB, so that's what I'm going to put down. AB, AB. And then I need another one. AB, AB. AB, 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 AB. Same for the signs. A, B, A, B. A, B, A, B. Okay. Now for the cosine, the cosine is going to start first. Okay. And then that leaves you with two sines here on the back. So you've got the sine of A multiplied with the sine of B. The sine of A multiplied with the sine of B. Okay? And then there is going to be a minus sign in between here and a plus sign here. Okay? Now for the sine, let me write this out for you. It's going to be the sine of A times the cosine of B, and then they switch. Cosine A, sine of B, and then here you've got sine of A, cosine B, cosine A, sine of B. And then for the sine function here, sine of A plus B, I'm going to have a plus sign in the middle, and then a minus sign in the middle. Okay? Now again, I've got some silly little mnemonics that'll help us to remember this. Okay? So as you saw me writing them down, when I have AB, that's what I put down. AB, AB. Okay? AB, AB. Now, the way I like to remember it, it's a silly little saying that the cosines are very antisocial creatures. So at the parties, they like to hang out amongst themselves. Okay? So only a cosine will only hang out with a cosine, and then that leaves the sine functions at the party to be left by themselves. Okay? And so you see that that's true for both of these identities. They're both cosines, so cosines by themselves, and sines forced to be by themselves. And since they are so antisocial, when everyone at the party is positive, they want to do the opposite. Okay? So when everyone in the party is negative, they want to be positive. Okay? And the sine functions are very social creatures. So they will force themselves to intermingle with functions that are not like them. Okay, so the sine functions want to get mixed in with other functions. So the sine will go talk to a cosine. Okay, and that's the same here. Okay, now of course, one more thing. Remember, the signs are social, so that when everyone's positive, they too are positive. When everyone is negative at the party, they will go with the flow and they'll also be negative. Okay? And when you are writing these identities, you see when you have a cosine, then you're going to write the cosine first. Cosine, cosine first. Sine, you start with sine first. Sine, sine first. Okay? So everyone always wants to get in the buffet line first. Okay? So I know it's crazy, but I think it might work. Okay? Now you've got identities for tangent. So now I've got the tangent of A plus B. So the identity is tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. Tangent of A minus B is very similar to the one here above. It's the tangent of A, okay, minus the tangent of B divided by 1 plus the tangent of A times the tangent of B. Okay? So when you're dealing with the sum and difference formulas for tangent, you're going to have a fraction. Okay? You're going to build fractions. And I say this right now, the tangent is not a linear operator. Okay? It does not move through sums and differences, but just to help you remember these formulas, you can think of it that way. Okay, just to, again, just to help you come up with this result that you can imagine that that's what is happening. The tangent goes to A, and the tangent going to B. Okay, then on the bottom you have 1 minus their product. So on the bottom you're multiplying those two individual functions. Okay. And then there are two signs. So the sign on the top is the same as the original sign. So it's a positive here, positive there. Then the sign on the bottom is going to be the opposite of that. Okay, and again, the same is true here. You can imagine and pretend. Okay, we can all wish, right? We can wish that the tangent were linear. So if it were a linear operator, it would go through that minus sign. So tangent A minus tangent B. Then on the bottom, we would then have to have 1 plus their product. Okay? And again, that sign matches that one, and the bottom sign is opposite of that original. Okay? So, how can these formulas help me? Well, let's, if you don't mind, I'm going to erase these two, running out of room. Let's say that I wanted to find the exact value for the sine of 105 degrees. Okay? Now that is not one of our special angles on the unit circle. Okay? So I'm going to ask myself, hey, can I take 105 and break it up? Can I write it as the sum or difference of two angles that we do have on the unit circle? And the answer is certainly yes. I could take a 60-degree angle from quadrant 1 and I could add that with the 45-degree angle. Okay? So that means that I could take this 105 degrees here, written in red, and then I can write it as a sum. Okay? So now you've got the sine of 60 degrees plus 45 degrees. Okay, and so that means that this is acting like the A that we have in our formula up above, and then plus angle B. Okay, so now let's apply our mnemonic to see if we can write this out. Okay, so I'm just going to take A, B, and then write AB, AB, right? A, 60 degrees, and then B, and then A, and B. Now remember, the sine functions are social creatures, so they want to get themselves mixed in with the other functions at the party. Okay, so the sine function is going to come first. It wants to jump into the buffet line first, and then it's going to get mixed in with a cosine. Okay, and now you're going to have to switch those. So it's going to be cosine of 60. Okay, and now the sine function is mingled with a cosine function, right? And remember, they're social creatures. S is social, right? So if everyone at the party is positive, they too will go with the flow and be positive. Okay. Now, the sine of 60 degrees, well, that's radical 3 over 2. The cosine of 45 degrees, well, that's radical 2 over 2. Cosine of 60 degrees is 1/2 times radical 2 over 2. Okay? And so that's going to now give me radical 6 over 4 plus radical 2 over 4. Okay? And so now I know that I have a sine function. I've given it an input, which is a angle, a degree here, and I've got my output. Okay? So my domain value, and there's my range value. Okay? And I certainly didn't need any calculator. The calculators would probably give me a decimal approximation anyways. Okay? Hope that helps you review those identities.